Okay. So C3, C4, and C5 is in series. They are in series. C3, C4, C5 are in series, but they are not in series with C1 and C2. So these two dudes are in series. These three girls are in series. This part is not in series with this part. So they are different. Okay. But if I were to add these two capacitors together, I would get C equivalent 1. And this guy, C equivalent 2. C equivalent 1 is in parallel to C equivalent 2. Now, what does it mean to be in parallel? What does it mean to be in parallel? What was the trick to understanding whether they are in parallel or not?
Different charge?
They have different charge, okay. If they have different charge, they should have the same voltage. So this is the opposite case. So if you have different charge, the voltage should be the same. If they have same charge, the voltage should be different. So same voltage. But what was the trick in understanding whether something is in parallel or not? What was the trick?
They are connected by the same dot.
Yes, they are connected by the same dot. Thank you. So if I have this dot over here and this dot over here, I can say, okay, the battery is in parallel with C equivalent 1 because they are connected by the same two dots on the sides. And this dot is also connected to C equivalent 2. So C equivalent 1 is in parallel with the battery. C equivalent 1 is also in parallel with C equivalent 2. Okay, because they are connected by the same dots on the sides. Okay, so that is a very, very important trick, okay, to understand whether something is in parallel or not. If you are confused, draw your dot, see whether they are connected by the same two dots. If they are not, then they are not in parallel to each other. So that is pretty easy, I think, for parallel. So the equation for parallel capacitors is C equivalent is equal to C1, C2 plus C, so on. And for series, it is C equivalent, 1 over C equivalent actually. 1 over C equivalent, 1 over C1, 1 over C2, and so on. 1 over C, blah, blah, blah. Okay, so that is your equation. What other equations do we need to know? Can't remember, but let me see. Is there anything that we missed? No, this is to form your equation. Okay, I think we're good. So let's continue with the example. So a capacitor, this one, have we done it? Kita stop mana? Okay, see this one. So a circuit below shows an arrangement of capacitors. This is too small. Let me just put myself somewhere else. Oh, this is bothering me. Okay, see. The circuit below shows an arrangement of capacitors consisting of capacitors C1, C2, and C3. Okay, so this is C1, C2, and C3. Calculate the equivalent capacitance of combined capacitors. We have done this one. So this guy is in series. So this is your C equivalent 1. C equivalent 1 is in parallel with C3. And from this, you get the whole C equivalent. Okay, let's just do it. I think you guys do remember. Because you're like, click, we click it. Okay, so let's do this. Calculate the equivalent capacitance of the combined capacitors. So the first thing that when I see a circuit is that I see, okay, what is in series and what is in parallel, right? So I can see that these two guys are in series. This dude is on its own. Okay, so let's just leave it there first. So I'm going to label this as C equivalent 1. Okay, let me just label it C12 because that is more accurate. C12, because C12 is equal to, this is in series, so 1 over C12 equals to 1 over C1 plus 1 over C2. C1 is 1 over 4 microfarad over 1 over 12 microfarad. And blah, 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 use your calculator. I'm pretty lazy about to do that. So C12, you will get whatever value that is. Can someone calculate that for me? quickly?
3.
Berapa? 3 kan?
3.
Dah buat betul. I remember someone mentioning 3 last time. Okay, so you have your C12 and you have C3. Now, are they in series or are they in parallel? They look like they are connected by the same wire, right? But in reality, when I put dots over here, I can say that, oh, C12 is connected by these 2 dots. C3 is also connected by these 2 dots, which means that C12 should be in parallel with C3. So C123 is equal to C12 plus C3. So that is 3 microfarad. C3 is 6 microfarad. We get 9 microfarad. Okay, so that is your part A. The next part is find the potential difference across capacitor C2. Okay, so find the potential difference. Potential difference, we know this. This is just V across capacitor C2. So this is the capacitor that we are looking for. Okay. Okay, so for a series circuit, when you have your battery, okay, just recap in case someone forgot. So if I have a battery of 5 volts, this 5 volt will be distributed across these 2 capacitors. Let's say this capacitors get 3 volt, this capacitor should get the remainder, which is 2 volt. But the sum of the voltages that these capacitors have should be equal to the total voltage of the battery. Okay, so this is one instance. What if I have like 3 over here, right? Okay, so what if I have another 3 capacitors at the bottom? Okay, so I told you about voltage in parallel should be the same. So let me write that down. Voltage, where was our recap? Okay, let me write it here. So voltage in parallel, okay. Voltage in parallel is the same, which is here. Voltage in parallel is the same. Can voltage in parallel is the same. So using this point that we discussed in recap, voltage in parallel should be the same. So if I have a 5 volt battery that is in parallel with this part, this portion, C equivalent 1 is parallel to 5 volt. C equivalent 2 is also parallel to 5 volt. What is the voltage of C equivalent 2 of the capacitors across C equivalent 2? What is the voltage?
5.
It should be 5, right? So anything that is in parallel with the battery should have the same voltage as the battery. So using this dot method, I can say C equivalent 1 is parallel to 5 volt. C equivalent 2 is also parallel to 5 volt. So the voltage across these 2 capacitors is 5 volt. The voltage across these 3 capacitors is 5 volt. Pandai-pandailah dia orang nak agih kan. But we have to know that the voltage sum of the voltage sum across the capacitors should be equal to 5 volt. Kita ada 5 volt je. So this is 5 volt, this is 5 volt. Kenapa? Why doesn't it add up? It's just like that. Parallel is not about adding. It's about being setara. It's, I don't know how to say this, but voltage macam tu. So something that is in parallel should have the same voltage. Okay. If I have a resistor over here, we have not learned about resistors yet. This dude, these 2 dudes should have a sum of 5 volt. Doesn't matter how many steps you have, how many branches you have. As long as they are in parallel, they should have 5 volts. Okay. Oopsie. Okay, so that was that. So now I'm going to ask you, what is the voltage across C3? What is the voltage across C3?
12.
12. 12. Is it 12? Okay, so
Yes.
jadi siapa jawab? Fakri dengan Umar ke?
Fakri.
Fakri. Okay.
Dan Umar.
Apa? Sorry, tak dengar.
Saya dan Umar yang jawab.
Saya tu siapa? Saya tak nampak lagi.
Fakri.
Fakri.
Okay. Okay, thank you. So this is 12 volt. What about C1 and C2?
Sum of 12.
12 volt as well. Okay. So how do I know what is the voltage for C2? What equation should I use? So I know the total is 12 volt now. So, but how do I find out what is distributed to C1? What is distributed to C2?
We need to do substitution.
Okay, substitution macam mana?
Let's say C1 and C2 is X and Y. I will do X plus Y is equal to 12. And in this case, the series, the charge is going to be the same. So I will use C is equal to QB for both sides, but I cancel C. Then I will get 12C. 12C1 is equal to 4C2, which is 12X
Okay, 12x is equal to
4Y.
4y.
Yeah,
Because they should have the same
charge.
charge.
And then we settle this.
Okay, so Fakri is using, tadi Fakri kan? Fakri is using math logic lah basically. So C equals to QV, they should have the same charge. So they should have the same charge. So it's equal to Q. Okay.
Doctor,
Yep.
is it okay if for the C and the V we take 12, but the C is different?
Is it okay
We
if
find the Q,
you find the Q?
meaning that for the C1, the C is 4, for the C2, the C is 12. So the Q amount will be different, right?
The Q,
Which total will
Oh.
be 12, Q1, Q2.
I remember I told you C1 plus C2 is equal to 12. So here, if you want to calculate for C1, the V1 is not 12. The
I
V1 is
see.
the pecahan, right? But the Q should be equal. So
Okay,
Fakri
okay.
got an idea about that, which is correct. So let's see. So how they did it. Okay, so V1 plus V2 should be equal to 12. So this is your V1, this is your V2. So we got that right, that one right. Q1 equals to Q2 equals to Q. So this one was what Fakri mentioned just now. So the Q are the same. So CA CA is the C equivalent of this part, which is C12 that we calculated earlier. So C12 voltage is the same. We know that C12, the whole voltage for C12 is 12, right? So C12, we know it was 3 times 12. So this would give us 36 microcoulomb. So kita cari charge dulu. So this is the step that they used. And then from here, after they found out the charge, they substitute into V2. We know the charge is the same for V1 as well. So V1 is Q, V2 is Q over C2, V1 is Q over C1. So here Q is 36 times 10 to the minus 6 from this part over here. Okay, divided by C2, 12, this guy. So you get 3 volts. So if this is untuk C2. If C2 gets 3 volts, then C1 should be, just by looking at this, 9, right? Okay, so let's see if you are right. 36 times 10 to the minus 6 divided by 4 micro. Okay, so okay. Tengok dari sini tahu dah. 10 to the minus 6 divided by micro is the same thing. 36 divided by 4 is 9. So yay, betul. So what was the trick to figuring out this problem? It was knowing that these guys have the same charge and different voltages. So you had two equations, you had two equations to use, which was what we had in the recap, right? So we had the equation for the voltage, different voltages, and we have the equation for the same charges, okay? And then we solve for the Q. Okay, so this is the step. You need to know whether it has the same voltage or not, whether it has the same charge or not. So this should be applied for both parallel and series. So let's take a look at other examples if we can reuse what we have learned here. Okay. So any questions about this one? Sorry. Any questions about this one? Did everyone understood what was done here? Is everyone okay?
Okay.
Okay.
Yes.
Okay, so I have another question for you. If this guy, the whole the I flowing through C12, okay, the I flowing through C12 is 36 microcoulomb. This is what we got, right? What is the I flowing through C3? Is it also 36 microcoulomb?
No.
Yes.
No.
Okay, the answer is no. Dudes in parallel do not have the same charge. Dudes in parallel. I don't know the word for that. But you guys know this guy and this guy have the same voltage. So definitely they do not have the same charge. So if I say the I flowing through the top part is 36 microcoulomb, contoh. So the I flowing through the bottom one is definitely not 36 microcoulomb unless C12 is equal to C3, then yes, they can have the same I. But here we know that C12 is not equal to C3, so they cannot have the same I, but they have the same voltages because they are in parallel. Okay, all right, so everyone's okay. So let's find out what is the charge flowing through C3. So this is like extra question. I hope everyone is with me. Everyone's still okay, eh? Baru je lagi ni.
Yeah.
Okay, so kita dah tahu what was the voltage V1 and V2. This one is 9. And the voltage at C3, we know this for sure. For sure, it's 12 volts. So ni tak payah berteka-teki. I told you it's in parallel, so it should definitely be 12 volts. So we know that the equation for a capacitor is C equals to Q over V. I want to know what is the Q across C3. How should I use this equation? I want to know the Q across C3. So Q3 lah. So this equation should be C3 equals to Q3 over V3. V3 kita tahu is 12, C3 is 6. So we can solve for Q easily lah sebenarnya. So 12 volts. So from here, we can know what is the Q. Okay, so what is the Q? Let me figure that out.
72.
Berapa?
72.
72.
72 microcoulomb. Okay,
Uh-uh.
so the answer is 72 microcoulomb. Okay, so we know this is Q1, this is Q2. What is the Q flowing through here? What is the Q flowing there? Apa?
108.
108. Oh, tambah terus. Yes, betul. So it's actually Q1 plus Q2. It's the summation. It's the total. Remember I told you we have one pipe of water that when it reaches a junction, it divides itself to Q1 and Q2. So to have Q1 and Q2, you need to start with something that is a total of Q1 and Q2, right? So Q1 here, Q2 here. So here that the Q that should be flowing is Q1 plus Q2. Okay, it's the sum. So that is also the same concept for current. Current and charges macam lebih kurang lah. Okay, moving on. So the capacitors in the following figure are arranged in parallel and in series. So, okay. What is in series and what is in parallel? Let's do this together. So can I ask Jaya? Dah lama tak panggil Jaya. Waktu awal dulu Asyik panggil Jaya aja. Sekarang tak panggil dah. Okay, Jaya, are you there? Excuse me. Is Jaya there? Or is Jaya absent?
Yes, miss.
Okay. So Jaya is C3 in series with C2.
No, it's in parallel.
It's in parallel. Okay. So Jaya said C3 is in parallel with C2. What about C1? Is C1 in series with C5?
Yes, miss.
So C1 is in series with C5. Okay. Okay, we will see. Okay, thank you, Jaya. So Jaya,
Yes.
C3 is in parallel with C2. That is correct. So C1 and C5, that looks kind of confusing, right? So can I ask Shasha lah. Shasha, is C4 in series with C5?
Yes.
Okay, yes. Thank you. Betul. So C4 is in series with C5 because if I have some water, the same water flows through C5 or they have the same current lah, basically. Okay. Okay. So C1, Jaya said C1 is in series with C5. I don't know about that. Kejap. I think not. Okay, so kita tengok. Okay, so C4 is in series with C5. So we need to find out the equivalent capacitance. I should read the question first. The capacitors in the following figure are arranged in parallel series. The drop in voltage across the two terminals A and B is found to be 14 volts. So between A and B should be 14 volts. What does it mean? It means that between A and B, there is a battery of 14 volts. So that is what it means. So when across A and B is 14 volts, it means that anything that is in parallel with A and B should be in 14 volts. Okay, so between A and B should be 14 volts. So this part is connecting to this part, is connecting to this part. Basically, this whole thing is a single point. This whole thing is a single point. So I can say, let's use a really, really big dot for that. They are connected by the same dots, okay? So I can say these are in series. These two are in parallel. And these two guys, I mean this part and this part is in series. So the voltage across C4 and C5, the total sum is 14. And the total sum of voltages across the downward part is also 14. Okay, so that is our situation here. Oops. Okay, so everyone please take note on the voltage across the two terminals A and B is 14 volts. It simply means that they are connected to a battery. So you get 14 volts across A to B. Okay, so that is what it means. So now they are asking you calculate the equivalent capacitance. Okay, so let's do that. Okay, so C4 and C5, can I ask, saya actually lupa nama. We have 36, so can I get Aisyah to do A? Cik, kesian pula buat A panjang kan. Okay, Aisyah buat C4, C5. Ishraf, is Ishraf there? Ishraf ada? Aisyah saya tahu ada.
Yes, ada.
Okay, so Ishraf C3 and C2. Okay, and then Lui, because I think I hardly ever call Lui. Lui C3, C2, sorry, C3, C2, C1. Okay, and then Fairoz, I want you to find what is the charge on C1. Is that going to be hard? I think you'll manage. Okay, so Fairoz, Fairoz hari tu dah buat dah kan? Okay, so orang lain lah. Let's ask Nisha. Can Nisha do B, the charge on C1? Okay, Nisha. And then, siapa yang saya selalu tak panggil? Cuba mengaku sikit. I think
Haikal.
Haikal jarang panggil kan? Ya ke? Okay, Haikal Haikal
Betul.
panggil kan?
Lalu lah.
Okay, Haikal, tak apa. Nanti
Haikal.
kita panggil dia orang pula. Haikal C,
Okay.
C ya? Okay, so
Okay.
before I forget, this was Ishraf and Aisha and Lui, if I remember correctly. And then the final one is Haikal. This one was Haikal was the last one. Okay. Siapa yang buat charge on C1? Forgot lah.
Nisha. Louis. Nisha.
Oh, Nisha. Okay, betul. Nisha. Okay, the rest of you, please try this on your own. Let's discuss later in like 10 minutes. 11:47. Kita akan discuss. Okay, so Ishraf, Aisha and Lui dapat the easiest question. So it should be 10 minutes, should be okay, right? Okay, so Nisha and Haikal kena bekerja keras sikit lah. Okay. So let's do that. I will talk to you back in 10 minutes. Oh, saya tutup ni pula. Sorry. Saya pun akan buat. So, korang mesti kena buat juga. Okay, is everyone done trying? Did everyone get the answer or not? Okay, so let's do this together. Okay, Haikal dengan Nisha boleh continue teruskan dengan perjuangan. Nanti saya panggil. Okay. So let's do this together. Okay, tadi saya panggil siapa? Kenapa saya padam tadi? Saya lupa. Okay, so Ishraf, Aisha and Lui. I think it was Aisha first. So Aisha, can you tell me what you're supposed to do? I forgot lah.
C4 and C5.
Okay, C4 and C5. Okay. Okay, so tell me.
Capacity in series, so equation dia 1 over C equivalent equals to
Okay.
1 over C4 plus 1 over C5.
Okay.
So 1 over C4 when value dia 1 over 4 microfarad plus 1 over 5 micro.
Eh.
5.
Okay.
C. Sorry, silap. Betul.
C equivalent is
C equivalent equals to 2.38.
2.38. Okay. Microfarad. Saya dapat 2.4. Saya salah kira ke? 1 over 5 and 1 over 4 plus 1 over 6. Oh, saya dapat 2.4. Dapat 2.38. Did everyone else got 2.38 or 2.4? Sebab ni kot.
Betul,
Pada
silap pada 1 over 5.
Okay, faham. So it should be 2.4. Okay, so it's 2.4. Okay, thank you. And then Ishraf. So this is C equivalent 1. Okay, so this is C equivalent 1. Let's label this as C for 5 is equal to 2.4 microfarad. Okay, Ishraf punya is C2 and C3, right? Mesti gagap ni. Okay, so C, macam mana nak dapatkan jawapan dia?
Sebabkan dia paralel, C equivalent equal to C1 tambah C2
C1?
tambah C2.
Tapi awak punya C3 kan?
Ikut nombor lah. So ikut formula.
Okay, tu formula dia. Okay, C3 and C2. Okay. That
Lepas
is
tu
tambah je.
dapat 5.
Dapat 5. Okay. Okay, let's dapat 5 microfarad according to Ishraf. So this part, let me label that. Let's use pink. So C23 is equal to 5 microfarad. Okay, and then Louis. Louis is C123.
1 over C123 equals to 1 over C1 plus 1 over C23.
1 over?
1 over 23 plus 1 over C1.
Plus
1
C1.
1 over 5 micro.
Okay, 1 over 5 micro. Oh, you put in the equation. Okay, faham. Okay, so you can do that as well. So the answer is, C1 is, let's write C12 lah. C23, sorry. It's 1 over C23 plus 1 over C1 because C23 is in series with C1. Okay, that is 1 over 5 plus 1 over 5. Okay. Okay.
So C123 equals to 2.5 micro.
All right. 2.5 microfarad. Okay. So C123 is 2.5 microfarad. So the top part is C45 2.4. The bottom part, I mean the whole thing, right, is 2.5. But if we're looking at this part only, it is C23, which is 5. Okay, thank you, Ishraf, Aisha, and Lui. And then we will go to Nisha. Nisha, are you ready? Nisha punya macam panjang sikit lah. But it's okay. I believe Nisha can do it. Nisha and Haikal.
Doktor boleh.
Okay, boleh So, sekejap saya buat new slide here. And then copy diagram sekejap. Sekejap. Tak. Okay. So let's hear it from this bottom part is 2.5. See, 1, 2, 3. Okay. Kenisha, what do you have? Let's hear it.
Mula-mula cari C equivalent untuk C2 dengan C3. So tambah je 3 tambah 2. And then dapat 5. Lepas tu kira C equivalent untuk C23 dengan C5.
Okay.
So 1 per 5 tambah 1 per 5. And then C equivalent dapat 2.5.
Okay.
And then masuk je dalam formula Q equals to CV, dapat 3 per 5.
C equivalent is 2.5 and we know that the V is
14
because it's in parallel with the battery. So you will get apa 30 berapa?
35 microfarad.
35 microfarad. And the question is asking you what is the charge at C1. So you're saying that memang 20 35. Betul?
Betul.
Okay, so if C1 has a charge of 35 microfarad, Nisha, what is the charge flowing through here? Come on, you can do it.
35?
Yeah, betul. 35, betul. Dia start dengan 35, dia pecah, lepas tu dia gabung balik jadi 35. So 35 is flowing through the C1. Okay, good. So Nisha found an easy way. I did it the hard way. So that was good actually. Okay, moving on. C is Haikal. This is B. Okay, so C is apa? Voltage across C1. So how did you find the voltage?
So yang C3 and C2 tu equals to A and C1 tu equals to B. Then A plus B equal to 14 volt.
14 volt.
And then
so V1
and then
V23 saya tulisnya apa cakap ni, V23 plus V1 should be equal to 14 volt. Okay.
And then C23 equal to 5.
V23 equals to 5.
C.
Oh, C23.
C.
C23 is equal to 5.
C1 equal to 5.
Okay. Lepas tu?
Macam nak sebut betul C 5 equal to Q over A.
C1 is equal to Q over VA. VA is your VA is your V1 This is VA. This is VB. Okay, VA.
So another one C23 equals to Q over B.
So another one is C23 equals to Q over VB. Okay, lepas tu macam mana nak kira untuk voltage number C1 ni?
Okay, so
So
kita samakan dia jadi like 5A equals to Q.
5A equals to Q. Oh, okay. So 5 microfarad times A equals to Q. Okay, so C1 VA equals to Q, C23
C23B.
equals to Q. And
then
okay.
kita buat persamaan serentak.
Okay, boleh macam tu. So C1 VA, C1 is 5 micro VA. Okay, VA ni V1 tau everyone. Plus 2 plus 5 microfarad VB equals to 14, right? So 5 kita boleh factor out 14 divided by 5 micro. Wait, the Q is the same. Kenapa saya equatekan dalam ni? Salah. Saya silap. So Q is the same. So kat mana awak substitute Q awak? Oh, okay, sorry, saya yang silap. Saya salah. Okay, so VB is equal to Q over C lah kan? Betul tak? Okay. VA is Q over C1. Okay, so this is Heikel's approach. And then daripada sini baru masukkan dalam this equation. So this is, sorry saya huru-hara sikit, Q over C23. Kita tahu C23 is 5 microfarad plus Q is and then VA is Q over C1, my 5 microfarad as well, equals to 14. Okay, and then lepas tu apa, Haikal? What card did you use? What was the
yang
Doktor, saya rasa ada silap sikit kat situ.
Kat mana?
Kan Haikal dah equatekan C23 V23 dengan Q kan. So kita just samakan C1 VA is equal to C23 VB.
Oh, okay. Bukan put in this equation. Okay. Haikal, kenapa awak tak beritahu saya? Awak macam
saya pening ke?
Apalah. Awak patutnya guide saya tahu.
Mana satu ni?
Okay, so awak equatekan Q dengan Q lah. Okay, so VB
saya potong Q tu
equals to VA C1. Okay.
Lepas tu C dia 55.
55 potong je lah. Okay, so VB is equal to VA. So VB is equal to VA. Let's say VB plus VB is equal to 14. So VB is 7, VA is also 7. Macam tu awak buat kan?
Sebab dia siri.
Okay. So there's another approach. Cara Haikal betul, panjang sikit but it's correct. New slide. So cara Nisha tadi cara Nisha. So we know that the equation is C equals to Q over V1. Sorry, C equals to Q over V. Nisha already found us this value Q, which is the Q flowing through C1. So this is Q1. Okay, so I know what is Q1, I know what is C1, I can solve for V. So C1, Q1, V, V1. Okay, so C1 is 5 microfarad, Q1 is 35 microfarad, you get V1. 35 divided by 5 is 7. Okay, sama je. It's okay, either way is okay, asalkan dapat jawapan. Panjang pun tak apa. Okay, so good job, everyone got it. So did anyone found it, you couldn't get the answer or you didn't understand the flow of the working process lah? Did you guys understand how to do it? Is there any confusion that I need to know, that I need to repeat myself? Bagi tahu je. Is everyone okay? So this is okay?
Okay.
Okay, Umar said okay, tapi dua orang ni yang selalu jawab. Orang lain macam mana? Saya tahu diorang ni selalu jawab okay. Orang lain macam mana? Is everyone else okay? Is Nick okay? Is Ayuni okay? Okay.
Okay, doctor.
Okay, miss.
Okay. Okay, so there are several ways to do this. You can do this the long way, you can do this the short way. Asalkan faham apa yang buat as long as everything else clicks. Macam mana nak tahu betul ke tak betul, you need to know what is parallel, you need to know what is series, what is the condition for parallel, what is the condition for series. Itu je basis for solving this. And then of course the equation C equals to Q over V. Yeah, if I got that right. Okay, moving on. Where is my pen? Oh, it's here. Okay, so this is the solution. Sama je sebenarnya. Yep, so we got it right. Okay. Oh, habis dah. Yay, chapter 17 dah habis. Yay, good job everyone. So that was chapter 17. So I'm gonna stop sharing this slide. So I'm gonna share your next slide. So should we take a break? Penat ke? Penat kot. Kan berapa? Oh, 12. Okay lah, boleh lah. Kasih 6 minute break. So 12:10, let's come back. Don't sleep. Okay, 1 more hour to go. 12:10, come back. Get your drink, whatever, your food, come back. We are starting on a new chapter. Okay. Cakap apa tadi?
Phone.
You want phone? Sekejap. This is chapter 18. What are you doing?
Hi, Yusof.
Ada orang cakap hi. Nah. Someone said hi, say hi. Hi. Why are you scared? Okay, Nana, you can take it. Can you close the door? Tak apa-apa lah. Okay je. Dah, close the door please. Okay, I hope everyone is back. Okay, you should be, because I told you to come back by 12:10. 12:10. Okay, so chapter 18. We're doing chapter 18 now. Okay. Yes, ada orang nak tanya ke? Nothing? Okay. Okay, so I'm going to start. Okay, so chapter 18. I'm still recording, right? Okay, yes. So chapter 18 is on direct current. Previously, we talked about capacitors. Capacitor ni is a component in an electric circuit. So we will see capacitors in this circuit, I think. And we will see resistors and other stuff. So capacitor tu macam introduction lah. Okay, so introduction to series and parallel punya concept. Okay, so for this chapter, we will be learning about DC circuit, DC components. There are two components that we will talk about, which is the battery and also the resistor. Okay, and then electric circuit analysis, we will learn on how to solve for currents, for voltages, for a circuit lah. Okay. All right, moving on. So electric conductors and insulators. We know electric conductors, the charge moves easily. Insulators prevent the move of charges. Where have we seen this? We saw this in chapter 17. We talked about capacitor plates, right? We have two metal plates and then we have an insulator, and only electric charges, negative electric charges can move. Okay, negative E. Is that how we, negative je lah. Okay, so only negative electric charges can move, whereas the ones here can only like reorient themselves because the charges cannot move. So we had, this was negative, this was positive, and then we had an electric field. And then because of this electric field, this guy wants to be positive, this guy wants to be negative. So we had another electric field in the capacitors, but the electric charges did not move because they were in the insulator. The charges only moved from conductors, which is the metal plates. So using that knowledge, kita akan tengok balik in this chapter. Tak berkaitan sangat, but ada overlap sikit lah. So for conductors, we know that it allows electric charge to travel through it easily, whereas insulator does not allow, we have seen this before, to travel through. Electric conductors are materials in which electric charges move freely in response to an electric force. So when we give battery to a capacitor, right? When we connect a capacitor to a battery, we are actually providing electric force for the charges to move. If there is no force given, then the charges will not move and they will just stay there, right? So the battery gives the force to move the charges. So this is the purpose of the battery. Freely in response to electric force and readily conducts electric charge. So copper, aluminum, and silver are good conductors. Okay, this is like general knowledge. Electric insulators are materials in which electric charges do not move freely. So we have seen that for the dielectric material in between the metal plates, and poorly conduct electric charge, glass, wood, and rubber. Okay, so that is the difference between conductors and insulators in general. Aside from electric conductors and insulators, there is also another category of materials called semiconductor. Okay, so if metals allow the charge to move freely, it means that the conduction band and the valence bands overlap. So if I have a charge over here, I can just, if I have a charge in the valence band, I can easily move it across, okay, because they are basically overlapped. So this is what it means when charges can move freely. Whereas in insulator, if the charge is in the valence band and I want to bring it to the conduction band, ada beberapa sebab kenapa kita nak bawa dia ke conduction band. So to get my charge to the other side, I need to supply energy. So the amount of energy that I need to supply to this charge to move it from the valence to the conduction is called the band gap. Okay, I'm not sure if you have learned about this term in chemistry, but band gap this is what it means. The energy to excite a charge from the valence to the conduction. Okay, so semiconductor is in between conductor and insulator. So if metals are like overlapping, so it can move freely. Insulator jauh, semiconductor tengah-tengah. So semiconductor ni, the energy to move the charge from the valence to the conduction band is smaller. And the nice thing about semiconductors is that we can change this gap to be bigger or smaller by fabrication process, by adding impurities, by increasing temperature, and so on. It depends on the material lah. Okay, why am I excited to talk about this? Because I use semiconductors. Okay, I am EE, right? I am electrical engineering. My degree is in EE. But when I did my PhD, I did it in photonics. So EE is about electric charges, right? Whereas for photonics, I deal with light. Photon is light, photonics. So this is my PhD work. My degree was in electrical, and then when I did my PhD, it was in photonics, which is the study of light. Electricity means the study of electric charges lah. Photonic is the study of light. So light also behaves in the same way as electricity because they are energy, both are energy, right? So semiconductors is used a lot in your electric components as switch, as band filters, and it is the same case for photonic applications. So sebenarnya sama, it's relatable. That's why I could move into photonics. Okay, so that's just like an intro. So semiconductors is really, really cool. I really like semiconductors and I work with semiconductors. I know I'm not chemistry background, but I use a lot of fabrication processes in my work as well, even though I'm like physics engineering, right? So that is something to think about if you are continuing your study after your degree. You don't have to confine yourself to one discipline. For example, you just want to do physics. You can actually overlap with chemistry, can overlap with engineering, you can overlap with mechanical, depends on what you want to do actually. So get your degree. If you want to further your study, whatever that you like, you can overlap with that. Just find the right supervisor to do that for you. Okay? So that's just like, saya tak tahu korang nak buat degree apa. Tapi saya rasa ramai nak buat medik Ke ramai nak buat engineering? Hopeful. Ke tak ada? No one wants to
Ada.
Ha? Tadi orang nak buat engineering? Ada. Siapa nak buat engineering? Ke tak ada?
Umar kot.
Siapa?
Bukan.
Umar nak apa? Medik
Nak
Oh, Umar nak medik. Fakri nak buat apa?
Fakri medik.
Oh, sama juga. Sofia? What about Sofia?
Ya.
Sofia nak buat apa degree?
Saya pun tak pasti.
Dalam pilihan letak apa?
Saya tak apply lagi.
Oh, tak apply lagi. Ingat dah deadline dah, belum What about everyone else? Semua orang nak buat medik Wow. Who
Saya tak nak medik tapi.
Oh,
Saya tak nak medik langsung.
Who is not doing medik?
Saya.
Saya.
Siapa tu?
Haikal.
Haikal nak buat apa?
Haikal pendidikan.
Oh, nak buat pendidikan? Pendidikan dalam?
Bio.
Oh. Okay, that's interesting. Anyone else nak buat pendidikan? So there's bio pendidikan, fizik pendidikan. Tak sure math ada ke tak.
My second choice is fizik pendidikan.
Siapa? Fakri
Oh,
okay, you want to be. Okay, that's good. Lagi? Siapa lagi? No one wants to share. What about Jaya, Divya? Medik juga? Divya is not there?
I'm here, doctor.
I haven't thought about it yet, doctor.
Oh, you haven't thought about it yet?
Yeah.
Okay. Anyone wants to share what they want to do for their degree? It's okay if you don't get it. It's fine. What is your like?
Amirul Haziq.
Amirul Haziq.
Haziq,
Yes.
Haziq.
Haziq nak buat apa?
Medik insyaAllah.
Oh, ramainya nak buat medik. Wow. I think like most of asasi nak buat medik sebenarnya. Ada tak nak buat vet? Nak buat vet? Tak ada. Wow. That's surprising sebab program vet kat UPM is one of the best lah, if not the best kat Malaysia. Engineering, I would say UPM is the second best, UM is the first one. Sebab UM ada banyak facilities lagi. Dari segi fizik, I'm not sure actually sebab saya engineering kan. Lagi, what about, no one wants to do bahasa, apa tu, fakulti bahasa, ada tak?
Shasha.
Oh, Shasha nak buat bahasa. I did not expect that. Okay, nice.
I'm interested in English literature.
Oh, English literature. Okay, that's good. What about maths? Anyone maths? No one maths?
Haziq.
Kenapa Haziq juga? Oh, Haziq pun nak maths juga? Banyak. Anyone else? Haziq is maths and medic. Fakri is pendidikan and medic. Umar is medic and
Engineering.
engineering. Okay, finally someone is doing engineering. Anyone else? Oh, what about Ishraf? Ishraf cakap itu macam nak engineering. Dia tak? Ishraf ambil apa?
Saya ambil apa yang ada.
Ambil apa yang ada? Oh, jangan tak kisah Kena kisah tau. Dia ni. Lepas tu nanti malu-malu. Siapa lagi? Kenapa saya tak ingat nama korang ni? Kejap.
Cik buat sains sukan sedap.
Siapa buat sains sukan?
Ichat.
Oh, okay.
Icap.
Sains sukan. Danish, what about Danish? Danish is not there. Sleeping. What about Anis? Amshar. Banyak orang ni.
Amshar Science Com.
Science apa?
Science Com. Science Computer.
Oh, Science Computer. Science Computer, Computer Science. Is that the same? Kejap. Tadi siapa yang nak buat Science Computer tu? Siapa tadi yang Fakri cakap tadi? Saya lupa ni.
Saya rasa Amshar.
Okay, Amshar. Is Amshar there?
Hujan doktor tak dengar.
Hah? Tak dengar?
Kat sini hujan, tak dengar.
Oh, okay. Okay, never mind.
Amshar dia cikgu.
Amshar jadi cikgu pula. Okay. Kenapa orang lain tolong jawabkan? Anyway, ada tak orang yang nak buat software engineering?
Saya.
Siapa tu? Siapa?
My second choice. Umar.
Oh, software engineering. Okay. Anyone else software engineering? Sebab software engineering is high in demand tau sekarang ni. Like everyone wants to do app or like have some web applications or have some e-banking. So all of that is software engineering sebenarnya. You develop the back end, you develop the front end. I don't know if you know what front end and back end means, but front end is your interface. Saya tak tahu nak cerita macam mana. Tapi kalau when you open an app and the one that you are interacting with, that is called the interface. You cannot see what is the process happening behind that interface, right? So the behind process is the back end. The one that you're seeing is called the interface ataupun graphical user interface. That is front end. Front and back. Agak common sense.
Betul.
Yep.
Software engineering tu kalau dekat UPM ni kenali sebagai apa? Kerja bachelor kejuruteraan sistem komputer dan komunikasi ke? Bukan.
Tak tahu.
Ke bachelor science computer system?
Saya tak tahulah, kejap. Nanti saya kena check balik yang tu. Saya tanya fakulti kejuruteraan. Sebab saya tak ambil kat sini. So, apa? Welcome. Anyone else wants to ask about engineering? So I can ask sekali harum questions about engineering. ada. So sikit je orang yang nak buat engineering. Okay, tak apalah. It's okay. As long as you like what you're doing, it's fine. Okay. So just have fun with your life. I mean, you can't have fun, like do something meaningful with your life. It doesn't matter what you do as long as you do your best and you bring benefit to our community. Okay. So that is what is important. Doesn't matter if you're a doctor, if you're an engineer, fakulti apa, cikgu ke, nak ajar tutoring pun, asalkan it brings benefit to other people, it is a good choice in my opinion. Like in my eyes, it is a good choice. So as long as it is a good way of earning money. Okay. Don't do weird things when you are doing your degree. Okay, dah tiba sentimental pula. Okay, so I'm gonna continue with chapter 18. So this is what I talked about. So that's fine. So semiconductor. Okay, so there's another type of material called superconductor. I think you have you have seen this word or this type of material in your high school. It is a material when it is below its critical temperature. Okay, critical temperature is always like in negative degrees Celsius. When it is below critical temperature, it will have superconductivity, hence the name superconductor lah. So there is zero resistance across the wire, which means that if you are transmitting electricity, you will not lose any energy. Dia akan operate at maximum capacity lah basically. So the question is, why don't we just use everything in critical temperature? Because application wise, it is expensive to make everything at critical temperature. Critical temperature ni is around this temperature, 133 to 138. Remember, 0 degrees Celsius is 278 Kelvin. If this is 133, you can imagine how many degrees it is. It is like minus berapa? Tak tahu. Kiralah sendiri. Tapi korang tahu lah, it should be negative degrees Celsius. So it's not practical to have things in minus degrees Celsius because first, it's expensive. Second, we can't touch it. It's like bahaya. So superconductors are not practical sebenarnya. So if we can get a superconductor that has a temperature of like 10 degrees Celsius or 12, then that is like awesome lah. Tapi yang ni chemistry lah. Kalau nak develop like materials ni is chemistry. So that's another option. Okay. Material engineering pun boleh juga. Material engineering and chemistry can do this. I mean like discover other new materials. Make new materials. Okay. So that's awesome. Okay, so that was just an introduction. Do you have to remember what is a semiconductor? What is a superconductor? No, actually no, it's just an introduction. So for this chapter, you need to know what is, how to define and calculate current in a conductor, apply Ohm's law in DC circuit, calculate electrical energy, and also power. Okay, moving on. So the simplest electric circuit should have electric energy source. We know this as battery and an electric device that uses up the energy. So our battery provides the energy and something has to use the energy such as resistors, such as bulbs or any device basically. And it should be connected in a closed circuit. So we talked about what closed circuit means. It means that the loop is not open at any place. So this is my loop of wire, right? So this means that everything is connected. It is not open. So that is a closed circuit. For current to flow, your circuit needs to be closed. I'm going to repeat myself. For current to flow, your circuit needs to be closed. If your switch, if there is a switch over here and it is open, which means that this part is not connected. Remember, the current is like water. If I have a pipe that is missing, the water flows out, right? Let's say the pipe is missing over here because it's open, the water just flows out. So there will be no current flowing in the circuit. So for current to flow, your circuit needs to be closed. The pipes should be all connected. The source that maintains the current in a closed circuit is called a source of electromotive force, or EMF. Remember, your battery gives you the force to move the charges. So electric motive force, the word force here. So EMF can be batteries, it can be generators. Generators also produce the electromotive force ataupun voltage lah. Okay, voltage to drive the current. So EMF source is connected to any device that use up the electric energy. So the device can be resistors, light bulbs, heating elements that you see in heaters. Do we have heater? Oh yes, macam shower kita ada heating element. So that is a type of heating element untuk memanaskan air. And then also radios, anything that uses electricity really is a type of device that uses up the energy, electric energy. Okay, so what is EMF? EMF, I told you it is, it can be a battery or it can be a generator. It is basically providing the force to move the charges, right? So the source that maintains the current in a closed circuit is called the source EMF, or it provides the force to move the current, the force to move the charges. A source of EMF can be thought of as a kind of charge pump that moves the charge from low potential to high potential by chemical, mechanical, or other means. So if you are using a battery, you are actually using chemical reaction to provide the energy. So chemical reaction produce energy, so that energy is used as a force to move the charges. Mechanical pun ada in the form of generator, ada, or a dynamo that is rotated using water, or yes, using water, and then that mechanical energy is converted into electricity, and the electricity is used to drive your current in the circuit. Okay, so batteries can be macam-macam lah sebenarnya. Okay, so in a circuit, a current flows due to the potential difference between the terminals of a battery. Remember, if we want current to flow, we need to have battery and also a closed circuit. So if I don't have this battery, basically I am not providing any energy to drive current. I'm not providing any energy to drive the current, which means that there will be no current flowing. So kena ada battery, nak ada current, kena ada battery. Nak ada current, kena ada battery, and also a closed circuit. As the charge moves a resistor, it loses its potential energy because a resistor is a device that uses up the electricity during collision with atoms in the resistor to be transformed into other energies such as heat or light. So resistor ni ada banyak jenis. Tapi typically resistors, when current flows through the resistor, it will produce some sort of heat. Tapi heat ni tak adalah banyak pun, sikit je. And another type of component, which is the bulb, when electricity flows through the bulb, it produces light. So the potential energy, the electric potential energy is converted into light. For the resistor, the electric potential energy is converted partly into heat. Okay, and so on. It depends on what device that is used. Okay, so the equation for current is Q over T, which is charge, the rate of charge flowing through a cross section of the wire. So this is the cross section. So current is the rate of charge. What is rate? Rate, it means over time. Rate means over time. Okay, so the rate of charge flowing through a cross section. So cross section that is perpendicular to the motion of charges. Okay, this cross section, kalau charge kita move, if our current moves like this is our cross section. So whatever charges that moves through this cross section over time is called current. Okay. So the SI unit for current is known as coulomb per second because this is Q, coulomb, this is second. So coulomb per second is also ampere. Okay, ampere is the SI unit for current. Electric flow when there is a potential difference. Remember, you need to have a battery and the rate of which the the charge moves is dependent on the resistance imposed by the conductor. If your resistance is high, then the electricity flowing through will be small. If your resistance is low, then the current flowing through the circuit is high. Nanti kita akan cakap lagi about this one. But the important part to know from this slide is this equation. I equals to Q over T. Current, the SI unit is ampere. It is the rate of charge per cross section that is flowing through the cross section. Okay. Okay, so example 18.1, the current in a wire is 0.6. So I is 0.68. How much charge flows through a point in wire in 5 seconds? Okay, so it's asking what is the Q if the time is 5? So equation untuk this, we know this is easy. Q over T. I is 0.6. Q is, we don't know, we are trying to find, and time is 5. So the Q is, what is that? 3? Don't know. 0.6 times 5, 3. So it is 3 coulomb. So this is the charge. This is the charge. Flows, the amount of charge that flows through a point in a wire in 5 seconds. Okay, so how can we imagine this situation? So remember, we are talking about, when we are talking about I, we are talking about the cross section and the charge that flows through the cross section lah. So if I have a charge here, this is berapa charge yang lalu through this hole dalam masa 5 saat. That is what the question is asking. So in 5 seconds, the charges that flows through this hole is 3 coulomb. Okay, so that is A. How many electrons pass through the point in 5 seconds? Okay, so charge is not equal to electrons, but I keep on like tersalah sebut, which is why I keep on betulkan myself. What is the word? Correcting myself. If I say electrons, I keep on like correcting myself to say charge, because charge and electrons is not the same. So Q is equal to NE. This was in chapter 17, I think, right? So Q is charge, N is a number, and E is electron punya charge. So Q is 3, and we want to know what is the number of electrons, and the charge for an electron is 1.6, I don't remember, let's see, 1.602 times 10 to the minus 19. So this is C per electron. Ke electron per C. Is it C per electron? Charge per electron. I think it's C per electron. Yes, it's C over electron. Okay, so this is C, and this is also C over electron. So dividing C with C gives you number of electrons. So the N is whatever that value is. Okay, so N is Q is NE, N is Q over E. So the 3C divided by 1.602 times 10 to the minus 16, 19. C over electrons, C divided by C cancels out. Electrons goes up there. So 1.87 times 10 to the 19 electrons. So the equation that we used here is this guy and this guy. So they are different. So that is something to remember and take note of. How many electrons per second pass through a particular section of wire? So it's talking about a section, a cross section, carrying current of 0.5. So I is 0.5. It's asking what is N per second. So it's asking T. Okay, so this is per second. This is T equals to 1. So the equation for I is Q over T. So if I is 0.5, the time is 1. So Q is 0.5 C. And it's asking how many electrons, sorry, Q is not equal to E, but charge ni is a total of E. So Q is NE. So this is 0.5, and we are trying to find, this is 1.602 times 10 to the minus 19, C over electrons. This is C. Okay, so sama je macam tadi. So this is the answer. 0.5 divided by E is 3.12 times 10 to the 10 to the 18 electrons per second. Okay, so that's pretty easy. So just equation. A current of 5 ampere exists in 10 ohm. Okay, so our R is 10 ohm. So for 2 minutes, T is 2 times 60. What time is it? Okay, 20 minutes to go. And then our current is I equals to 5 ampere. Okay. It's too loud. That's good. It's a robot. Okay, go sana, go sana. Okay, so a current of 5 exists in 10 ohm resistor for 2 minutes. So if I were to draw this, I can say that there is I flowing through this, which is equal to 5 ampere. Okay. Okay, so let's continue. I is equal to 5. So it's asking how many electrons pass through any cross-section of the resistor in this time. So we know this equation, I equals to Q over T, and this is 5, and this is Q. Okay, so 2 minutes is 120 second, right? So this is A. So Q is 5 times 120, which is 600. Okay, and then you know Q is equal to NE. Okay, it's pretty easy lah. I think that's how you do it. Kejap, let's see. Yeah. Tu tak ada kaitan pun dengan R. Lagipun kita tak belajar lagi pasal resistors. Okay, so Q, they use this equation, I equals to Q over T, found out the Q, and then Q equals to NE. It's just like the R is given there to trick you. Okay. Okay, and then moving on to resistance. Resistor in a conductor is due to the collisions of charge carrier with the atoms of the material. So a charge carrier ni, it can either be positive or negative, but for this case, let's just assume this charge carrier is current. Okay, untuk senangkan hidup kita, tak confuse. So let's just say current lah yang flowing. So the charge that comes from a current. What is current? Current is charge over time. So kita basically, when we have current flowing, we have charges flowing, right? Okay. So now, if I have a resistor actually imposes obstacles to my current, to my charges. So this is your obstacles. So let's say this is my charge. Let's abaikan perkataan free electron ni. Let's say this is my charge. Let's use a different color because it's almost similar. Let's use green. So this is my charge. So I have like a few charges that I want to pass through this pipe. A pipe full of obstacles. So this is a pipe full of obstacles, or also known as resistor. Okay, so if I want to pass these green balls through a pipe filled with red balls, and I want my green balls to reach the other side, it will take more time for the green balls to pass through compared with a pipe that is totally clean without the red balls, right? So in this situation, you can imagine the resistor. This is your resistor, and this is like a regular wire. Okay, so for a regular wire, there is minimal to zero resistance. Selalunya kita akan anggap it's a zero, ideal case. So for a regular wire, we will say the resistance is zero, which means that there is no obstacle when the current wants to flow. So when I have the same 4 green balls and I want it to pass through, and I want to see how long does it take for my green balls to reach the other end. Oops. For my 4 green balls to reach the other side of the pipe, I will see that in the regular wire it will be faster. Contohnya, I will take 1 second to see the 4 green balls at this point, whereas in a resistor, I will need to have like 5 seconds for all the 4 green balls to pass through because ada obstacle. Sebab dia nak lalu sini, terpelanting ke sini, planting ke sini, planting ke sini. So dia punya jarak perjalanan tu jauh. Jarak perjalanan tu lagi panjang compared to when it is clear. So kat sini jarak perjalanan dia is a straight line basically. Straight line. So straight line macam displacement lah. This guy has to go through a distance. It cannot go through displacement, which is the shortest distance. So this is why resistance imposes a resistor imposes resistance to the movement of current. That is why it's called a resistor. Okay, so a resistor is a passive two-terminal electrical component that implements electrical resistance. So it makes the current harder to flow through. Okay. So resistors are typically used to reduce current flow. Remember, I told you if your resistor is high, current is small. Okay. So remember, I is Q over T. If I take more time to pass through 4 balls, then my I is small. If I take like 1 second to pass through 4 balls, then my I is greater, right? So the I depends on the rate of how much charge can pass through a cross section or through the pipe. Okay, so that is the concept that you need to understand. Okay, and then we move on to Ohm's law. I would say that the early the early subtopics of this chapter is pretty boring. Okay, tapi kena tahu jugalah boring-boring pun. Okay, so Ohm's law is equals to V equals to IR. I know you've seen this in high school. So it's pretty straightforward. So V is for voltage, I is for current, and times with resistance. Okay, so typically V equals to IR is associated with a graph. This is the graph. You can write it as V over I or I over V. Okay, if you're talking about I over V, okay, so from this equation, kita zoom in, V equals to IR, I want to find out what is the slope for this graph. Okay, slope for this graph. So if my I is my y-axis and my V is my x-axis, okay, remember y equals to mx plus c. What is c? C is the intercept. Here, your intercept is at 0. So you can just abaikan. So y equals to mx. So y over x will equal to m, or your slope or your gradient. So here, your y is I and your x is V. This is your slope. What is I over V? I over V is 1 over R. So I over V, the slope is 1 over R. Okay, so if your graph is a V versus I, so this is your Y, this is your X. Y equals to mx plus c, assuming that your V equals to IR graph goes through 0. So your intercept is 0. Abaikan kat sini, 0. So to know the slope of this graph, I would need to put y over x equals to m. My y in this case is voltage. My x in this case is I. So V over I. Lemak tak cukup tempat pula. So this is V over I equals to V over I is equal to R. So your slope for this type of graph is R. Okay. So it depends on whether your I is the Y or your I is the X. You need to take note on that. Okay, so that is V equals to IR. Is there anything else that I need to talk about? So V is proportional to I. So the higher the V, the higher the I. Yeah, because it's proportional. Because resistance does not change. Resistance is constant, depending on the component that you put inside your circuit. So it doesn't change easily unless it's a tunable resistor, but we're not going to talk about that. So V is proportional to I. So based on this equation, if I say, I think you know what I'm going to say. If my V is high, my I is high. If my V is low, my I is low, because R is basically a constant. So it doesn't affect our value. I mean, it doesn't affect, it gives us a linear relationship lah. Okay, so V is proportional to I. Okay, moving on. So the measurement of current and voltage. This is your lab, basically. So in your lab, you will need to measure the current and measure the voltage across a resistor, across a bulb. I don't remember actually. I think it's across a resistor and other components. But basically, ammeter measures current. Okay, what time is it? Okay, 8 minutes to go. Measures current, and voltmeter, as the name says, measures voltage. Okay, so to measure current, you need to have your device in series. Because we know in series, the current flow is the same, right? So if I want to know what is the current for resistor I, what is the current for this resistor 1 lah. What is the current flowing through this resistor? So if I want to know what is the current flowing through that resistor, I need to fix my device. I need to put in my device in series, because we know that something that is in series will get the same I, right? So if I want to get the I, same I, so I need to have this in series. So this is in series. Walaupun nampak macam pelik, but that is in series. And for voltage, we know that if we want to measure the voltage across something, if I want to measure the voltage across a battery, I need to have it in parallel. If I want to measure a voltage across a capacitor, I need to have it in parallel. So here, the voltmeter needs to be connected to the resistor in parallel for the voltmeter to measure the voltage. Okay, so this is not in series. Okay, macam mana nak tahu dia series ke tak series? Whoops. So use the same trick as I mentioned to you before. The voltmeter, it should be in parallel with the resistor to measure the same voltage, right? So they should be connected to the same two dots. So are they connected to the same two dots? Yes, they are connected to A and B. So they are in parallel. So the voltmeter can do its job to measure the voltage. Whereas for the ammeter, let's say this is A and this is B. These are the two dots. So A is connected to this point, B is connected to the battery, which means that the ammeter is not in parallel with the current. And betul lah, dia tak sepatutnya in parallel lah. Okay, so it should be in series. So to draw your circuit, this is rupa dia in physical, in physical form. Is that the right word to use? But I think you understand what I'm saying. So this is the schematic. Schematic ni is a circuit diagram. Okay, so a voltmeter that is in parallel is drawn like this. This is your point A, this is your point B, and this is your ammeter. Okay, so this is the ammeter measures the I, this guy measures the V, the voltage. Okay, so another diagram, and I think we will stop here after we finish this slide. Okay, so in this diagram, I have a battery. So let me write that in the schematic. So this is positive, it's negative. And then there is a wire connected to a bulb. So connected to a bulb. Okay, buruknya bulb saya. Okay, so that is connected to a bulb. The battery is in series to the bulb. It's not in parallel. And then the bulb is in series to the ammeter. This is 0.835A, which means that it's measuring current. So this is ammeter, right? So the ammeter is connected here. This is positive, this is negative, okay? And then this is the wire. It is connected to the negative part of the battery. Okay, so that is your first loop. And then there is one more component that we did not put yet. This guy is measuring voltage. So this is our voltmeter, positive and negative. This is positive, negative. So here it is connected in parallel to the bulb. So in parallel to the bulb. I can put it here, right? Because this is how it looks like. But selalunya untuk menyenangkan kita ataupun memudahkan mata kita, we just put it outside. So V is outside here, and this is positive, this is negative. Okay, so here we can see that this is a positive terminal of the battery, this is a negative terminal of the battery, positive. Then we start with positive here, negative here, positive here, negative here. Dia macam cakap, dia macam terbalik. Dia tak ikutlah bateri ni. So if this is negative, positive, negative, positive, salah lah. Negative, positive, positive, negative, positive, negative. So dia bertemu dengan positive side of the battery. So bertemu dengan positive side of the battery. So positive, positive menghala ke positive side of the battery, negative menghala ke negative side of the battery. Okay, so that is your positive, negative lah kot. What is the right term? I don't remember. If I remember, nanti kita akan go through the next class. So that is your positive terminal and negative terminal of your voltmeter and ammeter. Okay, it's called terminal. Okay, so that is it for this class. Next class kita akan go through, kita belum lagi buat analysis. Kita akan go through resistor pula, component resistor. Okay, so if you have any questions, you are free to ask. Otherwise, we are done with class. Take care. If you have any concerns, you can ask me, especially about your degree. Other than that, if you have questions about web design pun boleh tanya. I can kumpul. I know I have like 15, chapter 15, chapter 16, chapter 17 yang ada soalan yang kita tak buat lagi. Kita kumpul sama-sama, kita akan buat revision. Okay? Alright. Take care everyone. Bye-bye. Stop sharing.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
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 Okay, Doctor.
Thank you, Doctor.
Welcome. Oh, Nick is doing biochem.